All right. Per what I said, I just wanted to walk through this last example that we didn't get to, so that you can review that. And this example explores the question. We've already seen that some curves do not have the same rate of change between all of their inputs. So the question is, well, what about a linear function? And so we're going to explore that. And this is really foundational as we move into calculus topics, but or just looking at rate of change for any function. So for a linear function, f of x equals mx plus b, the average rate of change by any 2 points is the same constant m. So it's telling us that it is constant, but we're going to explore it. And we're going to look at, don't worry about some of this other jargon about disagrees with what we learned in section 1.10. The slope is the average rate of change. On the other hand, if a function, blah, 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 we're just going to do this example right here. Okay, so we have a linear function, and we want to find the average rate of change between the following points. So for part A, average rate of change is f of 0 minus f of 1 over 0 minus 1. And I've got this linear function right here. And I'm just going to plug those values in to figure out what f of 0 and f of 1 are. So f of 0 is 3 times 0 minus 5. So this goes away because it's 0, so I get negative 5. F of 1 is 3 times 1 minus 5. So if I evaluate that, 3 minus 5, I get negative 2. So this is going to go right there, and this is going to go right there. And then I'm going to evaluate. So the average rate of change for part A is negative 5 minus negative 2 over 0 minus 1. So let's evaluate those. This changes to a positive 2. So I get negative 5 plus 2 over negative 1. Continue to simplify. I'm going to get negative 3 over negative 1, which gives me a slope of 3. That I'm hoping that your math spidey senses are tingling, because if you look, we've got a 3 in the slope spot. So let's check out part B. X is 3, x is 7. So part B, what happens when x is 3 and x is 7? We could make a prediction right now. I'm predicting that we're going to get a slope of 3 because that's our slope of our line. But just for due diligence, we're going to evaluate this. So average rate of change is f of 3 minus f of 7 over 3 minus 7. And then 3x minus 5 is our function, just a reminder. So I'm going to evaluate f of 3. So f of 3 is 3 times 3 minus 5. I get 9 minus 5, and I get 4. So this is going to go right there. We're going to do the same thing for 7. So f of 7 is 3 times 7 minus 5. So I get 21 minus 5 gives us 16. And this is going to replace this. And so now we do the average rate of change. We take the difference in the y values. So average rate of change is 4 minus 16 over 3 minus 7. So I get negative 12 on my numerator. I get negative 4 in my denominator. Negative divided by negative is a positive. 12 divided by 4 is 3. All right. Let's get into a little bit of calculus. So Part C gives us these 2 points. Doesn't matter what 2 points. They say point A and then point A plus H. So let's put those into our values, and then this is going to be a little bit more on the algebra side, but I'm confident in your abilities. So when x equals a and x, whoops, that's an x, equals a plus h, find the rate of change. All right, so the average rate of change is going to be f of a minus f of a plus h all over a minus the quantity a plus h. All right, so we can do the combining like terms thing in a second, but let's find out what f of a is. If we think back our function. So let's do this color. So f of a, I'm going to plug a in, 3 times a minus 5. And that's as simple as I get. I have a term with a, and I have a constant term, so that's all we got. All right, let's do when my input is a plus h here. So f of a plus h means I'm going to put a plus h in for my x minus 5. So I need to distribute and simplify this one. So I'm going to distribute 3, and I get 3a plus 3h minus 5. So now I have an a term, I have an h term, and I have a constant term. So I can't simplify that anymore. So what I'm going to do is I'm going to take this, and I'm going to put it right here. And I'm going to take this, and I'm going to put it right here. Okay? And then we're going to simplify. So I'm going to get my average rate of change is equal to, on top I've got 3a minus 5 minus the quantity 3a plus 3h minus 5. Okay, all over, what do we have in our numerator there? A minus quantity a plus h. All right. We have to distribute in the numerator, and then we have to distribute in the denominator here. And what I mean by that is we have to distribute this negative symbol to all of these values, and then I have to do it right here as well. And then we can start to combine like terms, like mathematicians do. All right, so numerator, 3a minus 5 minus 3a minus 3h plus 5. And in the denominator, I've got a minus h. All right, let's do the combine like terms thing. So in my numerator, if I look at all of my a values, I've got 3a and negative 3a. Oh, those are opposites. I've only got one h term, so that's going to come down here. And I'm just going to have it in my numerator, so negative 3h. Constant terms, I've got negative 5 and positive 5. Those are opposites, so they go away. All right, done with our numerator. If we look at our denominator, I've got a minus a, opposites, and I'm left with negative h. So I'm hoping that you see that, all right, we've got negative 3h over negative h. Negative divided by negative is a positive. H divided by h is 1, so I'm left with a positive 3. And so the question is, what do you notice? I've got a slope of 3, average rate of change. I've got a slope of 3, average rate of change. And I've got a slope of 3, average rate of change. So the conclusion I'm hoping you come to is that it doesn't matter what 2 points we look at. For any line, we're going to have the same rate of change, and it's equal to our slope. So I hope you found this helpful, and we'll talk soon.